A 90,000-ton warship spent nearly 5 years forward deployed without ever coming home. No strike jets, no cruise missiles. Most people have never heard of her, yet her crew runs non-stop helicopter operations, sweeping mines from shipping lanes the global economy depends on. This is life inside the Navy's largest expeditionary sea base during combat operations. How she actually works will change what you think a warship can be. The Expeditionary Sea Base exists for a single reason: to bring the functions of a forward operating base out to sea, wherever the Navy needs it. According to official Navy doctrine, the ESB is defined by 4 core capabilities. First, it provides aviation facilities, a 4-spot flight deck, a hangar built for heavy-lift helicopters and tilt rotors, and all the fuel, armament, and maintenance infrastructure to keep them flying around the clock. Second, it offers berthing and habitability, with living space for a blended crew of civilian mariners, Navy personnel, and up to 350 mission specialists. Third, the ESB delivers equipment staging support with vast reconfigurable decks and cargo holds that can store vehicles, mine countermeasure kits, and humanitarian supplies. Fourth, it serves as a command and control hub, with dedicated operation centers and secure communications to coordinate joint missions far from shore. They are not just features, they are the reason the ESB exists. By combining aviation, berthing, staging, and command and control in a single platform, the ship can sustain critical missions in places where no land base is available, and keep the fleet operating when the nearest port is thousands of miles away. Stretching nearly 240 meters from bow to stern and measuring 50 meters across, the Expeditionary Sea Base dwarfs most vessels it shares the ocean with. At full load, it displaces around 90,000 tons, more than many cruise liners. Yet its top speed is a modest 15 knots. The reason for this trade-off is endurance. Designers gave up high speed in favor of a massive reinforced flight deck and cavernous mission bays. The result is a ship that can travel 9,500 nautical miles without refueling, validated in Department of Defense endurance trials. This range allows the ESB to remain on station for months, sustaining operations when the nearest port is an ocean away. Stability is another priority. A 50-meter beam, active fin stabilizers, and automated ballast systems keep the deck steady, even when heavy helicopters are landing or the sea turns rough. These choices shape the crew's reality. Days and weeks blend together as the ship holds position far from shore, its vast size enabling a floating routine of work, rest, and readiness that is measured not in hours, but in the slow passage of time at sea. Every day on the Expeditionary Sea Base begins with a simple fact: 2 crews, 2 systems, 1 ship. 44 civilian mariners from Military Sealift Command handle the core, the engines, navigation, and logistics that keep the platform moving and livable. Alongside them, 101 Navy personnel drive the mission, flight deck operations, command and control, and security. The numbers matter, but the real story is how these groups work together, often under pressure. The civilian chief engineer answers to the Military Sealift Command chain, while the Navy captain holds ultimate authority for anything tied to safety or combat readiness. Decisions about launching aircraft or shifting maintenance windows pass through a dual approval process outlined in a formal Memorandum of Understanding. On a typical morning, a Military Sealift Command engineer might flag a fuel system check just as the Navy flight deck officer is prepping for a high-tempo launch cycle. Sometimes this means a few extra minutes of negotiation, a small delay on paper, but a real friction point when the tempo ramps up. Yet this blended model brings strengths too. Civilian mariners bring deep technical experience and continuity, while Navy detachments rotate in fresh perspectives and operational urgency. The result is a culture shaped by collaboration and at times careful compromise, one that sets the tone for every mission and every long stretch at sea. Every schedule on the Expeditionary sea base bends to the rhythm of its aviation cycle. The ship's four-spot flight deck, engineered by NASCO, is more than a slab of reinforced steel. It's the metronome that sets the pace for everyone aboard. At any hour, a heavy-lift helicopter or tilt rotor could be spinning up, while another is landing, and a third is being refueled and checked for its next launch. The Navy aviation officer, perched above the deck with a radio in hand and a tablet full of turnaround metrics, watches the clock. 24 minutes, start to finish, is the standard for getting a helicopter from touchdown to launch ready again. That number isn't just a technical feat, it's the heartbeat that drives meals, sleep, and maintenance. The deck supports an evolving mix. MH-53Es, MH-60SSs, V-22 Ospreys, sometimes a palletized drone, all moving through the same relentless cycle: launch, recover, refuel, repair, and launch again. Crew rotations, briefings, and even the timing of hot meals are set to the tempo of this cycle. When the operational tempo surges, the pressure lands first on the aviation teams, but the entire ship feels it, from the hangar to the galley. The flight deck's 4 spots aren't just a number, they are the pulse points of the ESB, dictating the flow of every day and every mission. A sudden mine threat changes the tempo instantly. Orders come down to clear a vital shipping corridor, and do it fast. The mission deck transforms overnight. Modular containers are rolled aside and replaced by racks of mine neutralization kits and spare parts. One flight spot is dedicated to airborne mine countermeasures, AMCM operations. MH-60S. Seahawks are fitted with specialized gear: sonar sleds, magnetic tows, and explosive charges. The Navy aviation officer, running on caffeine and adrenaline, coordinates a surge cycle. Launch windows tighten. Pilots and deck crews rotate through briefings, don survival vests, and step onto the deck before dawn. Within 2 hours, 3 helicopters lift off, each trailing cables and sensors over the water. Below, the mission deck hums with activity. Technicians prep the next loadout, engineers monitor fuel and hydraulic lines, and handlers move equipment as soon as it is cleared. Every sortie is tracked on a digital board with flight time, sweep pattern, and next refuel. Communication with the operations center is constant. The pressure is real. Clearing mines is not just another task. It is the difference between safe passage for 150 merchant ships or a blockade that could choke a region. There is no margin for error and no time for rest. During a surge, the ESB becomes a test of human endurance as much as machinery. The galley works overtime, serving up to 500 meals a day, eggs at midnight, coffee always brewing, sandwiches prepped for grab and go between evolutions. Crew members slip in for food whenever the flight schedule allows, sometimes wolfing down dinner in 5 minutes before heading back to the deck or the mission bay. Sleep comes in short blocks, divided by 6-hour watch rotations for deck crew and 4-hour shifts for those on the bridge. Even off watch, the hum of ventilation, the distant thump of rotor blades, and the constant vibration of engines make true rest elusive. Navy fatigue policy requires at least 8 hours of rest in every 24 hours. But during high-tempo periods, that often means catching naps in designated rest zones or bunking down wherever there is a quiet corner. Wearable monitors track sleep and alertness, and the medical staff keeps a close eye on anyone showing signs of exhaustion. The gym, recreation room, and internet lounge offer brief escapes. But most people measure downtime in minutes, not hours. Maintenance never stops. someone is always fixing a hydraulic line, running diagnostics, or prepping gear for the next cycle. This relentless routine is not just background noise, it is the price of keeping the ship ready, the sea lanes open, and everyone safe in a place where the clock never really stops. Inside the Combat Information Center, rows of consoles glow with tactical data, radio chatter, and encrypted feeds. The Command and Control Watch Officer, flanked by a small team, keeps one eye on the Link 16 terminal and another on the Joint Tactical Information Distribution System, tracking every aircraft, boat, and threat in the operating area. Every mission begins with a pre-brief. Pilots, deck crew, and mission planners gather around digital maps, reviewing risk assessments and asset allocations. Once the plan is finalized, the flight deck receives a launch packet, including loadout charts, safety checklists, and timing windows delivered on a secure network. Before the first rotor spins, the communications suite runs a 30-minute cycle of comm checks, linking the ship to Fleet Command via SATCOM and verifying every encrypted channel is clear. As operations unfold, the watch officer monitors the flow of information, updating the air picture, logging new taskings, and relaying rapid retasking orders if the threat shifts. Every 30 minutes, another comm check. Every message is logged, every link tested. The rhythm is relentless, but precise. The Combat Information Center turns a constant stream of data into coordinated action, making the difference between routine and crisis invisible to those above deck. Here, decisions move from the tactical, launching a helicopter and shifting a sweep pattern, to the strategic, as the ship's role in the wider theater is quietly shaped by the cadence of briefings, encrypted links, and the steady hand of command. Persistent forward basing is both the greatest strength and the hardest challenge of the ESB. When the puller first arrived in Bahrain, the plan was simple. Stay on station, ready to launch missions at a moment's notice, for as long as the operational picture demanded. The Herschel Woody Williams followed, forward deployed to Ceuta Bay, Crete, and remained in the Mediterranean for nearly 5 years. This kind of presence, years at sea away from home port, demands more than just a sturdy hull and a deep fuel tank. It tests every system and every person aboard. The maintenance burden grows with each month. Worn propulsion parts, ballast pumps pushed to their limits, and the constant need for dry dock periods, like the mid-deployment overhaul in Malta for Woody Williams. Spare parts sometimes run short. Crew rotations are staggered, but fatigue builds. Even with a gym, a chapel, and a steady rotation of fresh faces, the reality is simple. Life shrinks to the routines of the ship, the endless cycle of watches, maintenance, and meal breaks squeezed between evolutions. By the time Woody Williams returned to Norfolk in April 2025, the crew had logged thousands of flight deck sorties and supported dozens of joint exercises, but the real achievement was simply enduring, holding the line day after day far from shore so the rest of the fleet could keep moving forward. Expeditionary sea bases hold the line in strategic waters, quietly, relentlessly, without headlines. Their endurance and blended crews make global logistics possible where no port exists. As sea lanes face new threats, these persistent, unglamorous platforms keep the world's commerce moving. Thank you for watching.